Does this look familiar to you? How many times have you seen a newspaper article that tells you some new finding of something that you're supposed to do that previously you were told you weren't supposed to do? We get bombarded by these sorts of news stories all the time. One of the major goals of this course is to give you some tools so that you can ignore some of that material and make decisions about which things to pay attention to. And that's what we are going to be doing in this next two videos. Key to understanding which to ignore and which to pay attention to is to understand that not all experiments in nutrition are equal. Some are better than others, and there is a sequence in which experiments are done. Throughout the history of an investigation, you don't arrive at a conclusion about an issue of nutrition with just one paper. And once you understand that, you can wait until the right type of study is presented. But in order to do that, you need to understand what the right type of study is, and that requires that you know what the types are in the first place. So that's what we're going to be working on in this next two videos. Here is a take-home chart that you can use to evaluate any information that you're bombarded with. Before you buy into any piece of information, you can just walk through this checklist and look for the answers that are on the right-hand side, and only act when what you see matches all these measures. What we're going to be doing is going through each one of these line by line, and I'll show you the process by which you can evaluate studies that are reported to you. Okay. So we're going to start with what is the source. Now, as I'm working through this, I find it really helps to have an example to explain. So I'm going to be working with the question of, should you take vitamin E supplements? So here's an ad for a vitamin E supplement, and here's what the claims are. It says vitamin E acts as an antioxidant, prevents cell damage. It prevents the formation of free radicals. It can retard cellular aging, supply oxygen to the body, and protect your lungs against air pollution. It can prevent scarring, topically as well as when taken internally. Also works as a vasodilator and anticoagulant. So all of these properties are on the label, and these are claims that are being made. So in the chapter for the complementary and alternative nutrition, there's a big part of it is about antioxidants. And this has become a major area of research, and the jury is still out on whether these antioxidants actually do anything or not. You can get them to act in a test tube, but does that really make difference for your health? So we're going to work on what is the evidence that vitamin E does anything helpful in the body. So I chose this topic because it's actually sort of controversial. Here is if you go on the internet and you put in vitamin E and cancer, you will come up with this result. So here is a website that has something that sounds good, natural news. We all like to be natural. And it says that the science that's coming out is junk science. So let's go through this process and we will evaluate what the data says. So the first question that you need to ask is, what is the source of the information that you're getting? Many times where we get the source from is TV. There's a news report, or maybe the newspaper, or maybe we're doodling around on the internet and we come across something. So the first thing to do is to ask, what is the source that you're looking at? One problem is that when there is new research that comes out, there may be 100 different science writers in the popular media that will report on it, and it looks like there are 100 people saying that it's true, when in fact there's only one source that's saying it's true and everybody else is just repeating it. So it's important to weigh each study by itself. So what you need to do is go back to the original source. So look for the scholarly, peer-reviewed primary source of the information. So all of these words, scholarly, peer-reviewed, and primary, have specific meanings, and I'm going to go through each of those in turn. So what is a scholarly source? A scholarly source is written by experts in the field, and it's written for a particular purpose and for a particular audience. So 1, 2, 3 things have to be true in order for it to be scholarly. There are many really good sources out there of information, but for various reasons they are not scholarly. So for example, one of my favorite newspapers to get news about the latest studies coming out is called Science Daily. But what it is something that's written by journalists. They have bachelor's degree, maybe master's degree in journalism, and they tend to specialize. So maybe they actually know some science, but they are not experts in the field. Scholarly literature is written by experts in the field. Another great source that everybody relies on is WebMD. It's written by MDs, right, who, presumably they choose doctors who are specialists in whatever field that they're writing about. But the audience that it's written for is the lay reader. And that's really helpful when you're trying to have things explained to you, but it's not a scholarly source. This one is pretty obvious. There are many, especially websites out there, that will present information to you, but their underlying reason for putting out that information is something other than advancing knowledge in the field. Of course, there is, those websites who have an underlying monetary motive. They want to sell you something. But there are also websites out there where they have a belief. Maybe they have a belief that natural is good and that medicine is bad, and they want to promote that belief. So what you want to make sure is that the only purpose that they have is for advancing knowledge in the field, and that they are not biased in any way. about this particular source, naturalnews.com, it is not a scholarly source, and there's many reasons why, but the simplest one is if you look up who this person is, this is not an expert in the field. This is someone who is a science writer, and there's actually more behind it, and if you're interested, you can see everything about that. So, once you know that what you're looking at is a scholarly source, the next question is it peer-reviewed? You can have something that's written by a scholar for the scholarly audience, but it hasn't gone through the fact-checking peer review process. The reason it's important for you to use only peer-reviewed sources is if it's peer-reviewed, it means that you can rely on the conclusions in the paper without necessarily having to go back and check and understand their experiments. Really, that's a pretty cool thing. So, what is peer review? Peer review is a process. And when somebody writes something, it doesn't get published automatically. Instead, it has to go through this trial to make sure that it is worthy of publication in a scholarly peer-reviewed journal. Right? And if it is, then the fact that it's published in that journal will make it so that you can trust the conclusions. So let me talk a little bit about the process of peer review. What happens is you have an author who is doing experiments, and then they write up a paper and they mail it away to the editor of a particular journal that they think would be appropriate for their results. What the editor does is it will read the paper and make an initial decision. First of all, it decides, does this paper fit my particular journal? If you have the Journal of Thoracic Surgery and you're writing a paper about algae, that may not be the right journal to send it to. So sometimes it will be rejected just on that basis. But if the editor feels like, your paper is a good match for their journal, then what they will do is contact some people who they know are experts in the field, and ask those experts, who are called reviewers, to read over your paper and check and make sure that all of the data that's in your paper matches what your conclusions are. In other words, did you do the experiment right? Are you missing controls? Is the science sound? And most importantly of all, are your conclusions justified by the data? If it is, then what they will do is send the paper back and say, yeah, it looks good, and the editor will publish it. If it's not, then what they can do is they can either say, we want you to do these additional experiments, or we don't like what you said here, you've got to go back and change that. The editor will send it back to the author and ask them to make the changes, and they'll try it again. Okay? So only when the paper matches the criteria set by these anonymous experts will it be published. Okay. So that process ensures that what is on those peer-reviewed journals, it's as good as anybody's going to get. Who else do you want to review your papers? You want the papers that you're relying on. You want it to be somebody who knows what they're doing. So how do you know a journal is peer-reviewed? Well, technically, sometimes you go on the website, or you pick up the bound version of the article, and sometimes they will say right up front, it's peer-reviewed. That's easy. Okay. Sometimes, though, you can find it have to look for it obliquely. So look at this one here. Cancer Prevention Research is the name of the journal. Information for reviewers, that suggests that it is peer-reviewed. So that's sort of the hard way to do it. Most people don't bother to do this. Instead, most people use a shortcut, which is there are these databases which limit the search to only peer-reviewed scholarly journals. So that way, if you use the database and you know that it's limited in this way, and you find an article, boom, you're done. You don't even have to think about it. A lot of people like to use Google. I certainly use Google all the time. What you should know about Google is, of course, it gives you absolutely everything. And that's what's great about it. You can shop, you can find, nutty websites. There's a lot of different uses for Google, but it's all inclusive. Google Scholar is an attempt to include peer-reviewed papers, scholarly papers, but unfortunately what Google Scholar does is it gives you access to the scholarly papers, but it will also give you things that are not scholarly. So you can't use the fact that you find it on Google Scholar as a guarantee that it is a scholarly peer-reviewed paper. So what I'm going to have you do in this course is use a version of a database called MEDLINE. And MEDLINE only will search through journal articles that are peer-reviewed, scholarly, and that happen to be on medical topics. And since nutrition is mainly about medical topics, that is the database that's most relevant to us. Okay. So, what I'm going to have you do is to start working on an assignment that we're going to do in class. What I want to do is split the groups up into 4. So on the first day of class, I gave you a card, the 3x5 index card, and it had one of these symbols on it. Hopefully you remembered to write it down. So based on what your symbol is, what I'd like for you to do is to take on the particular functional component, and do a little research on it. Okay. So stop right now and just write down someplace what your assignment is. Okay, so what you're going to be doing with this is I'm going to ask you to find a peer-reviewed scholarly article that presents the evidence that this particular thing that you've been assigned affects memory. Okay. So let's talk about how to get to MEDLINE, because that's what we're going to do to find a scholarly peer-reviewed article on how your functional component affects memory. So let's start with the UMBC library. If you're logged in, it gives you some functions and access to free articles that you don't get when you're not logged in through the library. So start there. So here we are at the library's website. And what I want you to do is to go to databases, okay, and search for MEDLINE. That's the database that we're going to use. Now, if at any point you can't remember the name of it, because it all sounds the same, you can also use these subject guides. Okay. And the subject guides, you want to use biological sciences, and then it's article databases at the top, and there is MEDLINE. And here it's authoritative information on medicine, nursing, diagnostic. That should make it pretty clear that that's the one that you want. Okay, PubMed is another one, but MEDLINE has some extra features. The search function allows you to do more, so that's the one that we're going to use, and that's actually, you have to pay for that one. So this is what the search function looks like. Now, for my purposes, what I want to do is I want to look for scholarly articles on vitamin E and cancer. Okay. All right. So then you just go and you click. And what you get is a list of all of these articles. Now, all of them are scholarly, all of them are peer-reviewed, otherwise they wouldn't be here. But look at this. There's 2,805 papers on this topic. Let me just show you a couple things to narrow it down. At the front of every article, there will be an abstract, which is a brief summary of everything that's in the paper. So if you choose, instead of searching everywhere and everything, and you search only for that text in the abstract, that could cut it down. So I'm going from 2,805 to 1,856, I lost about 1,000. Another thing is if you want to make it really specific, you could also specify that those words have to be somewhere in the title. Okay, so let's see if that will narrow things down. Now I've got 300 results. Believe it or not, that's workable. Okay, so let's go back to that. All right, so what I'd like for you to do now is to go to MEDLINE and to do a search, except for this time you're going to put in the name of your functional component, and then you're going to put in memory instead of cancer. Okay, so go ahead and do that. Okay, so now what you have is a list of papers. Hopefully you don't have too many, although I think I gave you a narrow enough topic. You may have up to 60 papers to look at. So the next question is, you want to make sure that you're looking at a primary source. In those lists of articles, there is going to be a combination of two different types, primary sources and secondary sources. The primary sources are the articles that are written by the people who actually do the research. So in that diagram I showed you, there was somebody working at the microscope. She is the one who is going to write and actually describe the experiment that she did and how things turned out. So it's her experiment and her experiment only. So when you write these papers, they appear and they describe one experiment. And as you're going to see, experiments are repeated. That's how scientists make sure that, our work is sound, is other people repeat them. So every now and then, the journal editor, remember them? He will ask one of his experts, you know, there's been a whole lot of papers written on this same topic. Would you please write me an article that just summarizes everything that's been written on this topic so that our readers can have a sense, so that they don't have to read 10, 20, 30, 40 papers. So the author, the expert that is asked, will do sort of like what you do when you write a term paper and send it to the editor, and that will be published. And that's called a review article. So in that list, you have a combination of primary sources and secondary sources. We are going to be counting primary sources later on, so it's important that you not count the secondary sources for the review articles. So how do you tell the primary sources from the secondary sources? One easy way to do it is to actually look at the abstract itself. Primary sources, because they describe experiments, the author has to tell what it is that they actually did in their experiment. So there will be a section in that paper that's called Materials and Methods that describes one experiment. And in a secondary source, on the other hand, because they are describing lots of different experiments and just summarizing the results, the conclusions, and putting it all together, like there's 10 papers that all agreed on this and that, they will not have a materials and methods section. They will also not have a results section because they didn't do an experiment, so there's no experimental results. It will read pretty much like a term paper. Okay. Another thing is that sometimes they will come right out and say it. Somewhere it will say review. That's nice. They'll also say things like an overview, or they'll pose some sort of like tricky little question with a question mark after. Those are all tells that this is a review article. So what I'd like for you to do now is to look through that list, that results list from your PubMed search, and see if you can find one review article and one primary article in your results list. Okay, so now that you know that you have a primary source that you're looking at, the next thing to do is to look at the type of study that it is. I'm going to put, although there's 5 or 6 different categories in your textbook, I'm going to put them in 2 categories. Is it a clinical trial or a correlational study? If it's what you want, is you want to look only at clinical trials. And I'll talk about why that is later. So for now, what I'd like for you to do is to review this chart, which talks about what a clinical trial is, and the case control studies and the epidemiological studies are the correlational studies. So look at your primary article and try to figure out, does it fit better with this description, or with a clinical trial? So once you've done that, I'd like for you to open up the next tutorial. I think it's 1E, and we are going to continue with these results that you have.